So let's be starting with the FSS code. So this is we are regarding about the doors. Like there's a bulkhead which is kind of A, B, and C. It can be A60, A30, or A20 like that. So basically, it resists the flame and smoke for 1 hour. Temperature up to 159 degrees Celsius from the normal temperature, and maximum 180 degrees Celsius. And the A60, that 60 denotes the minutes up to what time it will resist, and A30 similar 30 minutes it will resist for. Apart from that, till this time, the okay, now basically it says like it will resist that temperature, uh, 150 and 1, I guess 159 and 180, for 1 hour. Okay, that temperature will not rise more than that. Um, and that it will not allow the fire to come out and smoke come out for 1 hour. And it and the temperature part is different, which says that the temperature of the bulkhead will not rise up to this temperature 180 and 150, and up to at what time it will not resist, that is A60, A20 denotes like is for 60 minutes, for 30 minutes, the temperature will not rise more than that. Okay, now coming to the other point, that part b says that uh, instead of that 150 it becomes 225. Sorry, instead of something is there, 225 and 180, the temperature will not rise on the normal temperature 180, and normally not max more than 225. This is the deviation. And for just like A has three temperature, A60, A30, A20, but B has only two, I guess B10 and B20, like that, for very short duration. And C kind of bulkhead, fire door bulkhead, where it is don't have any as specific requirements of A and B, but it says that B should be equivalent to the bulkhead of that wherever it is fitted. So I'm not remembering the temperature it was, so just bearing. So what I missed is A30, A60 I correct, A30 and A15, not 20. Okay. Now, a division constructed of steel or equivalent material and capable of preventing the passage of smoke and for 1 hour. Okay. Division bucket should be insulated with non-combustible material so that the to a fire opposite to the fire the opposite to the fire opposite to a fire, the average temperature will not rise more than 139. I guess I've told 139 only. So 139 and maximum 180 degree and above. I guess I have told 150 if I'm not wrong. So it's 139 and 180, and the other is 225 if I'm not wrong. 225 something like that. 180 and 225. So 225 is there when 139 is there. Oh. So again I made a mistake. B15 and B0. Okay. So B0 is there. So this is we have to remember. Must prevent the stated temperature for at least 30 minutes. Okay, and there is insulation capable for the flame for this is a half an hour. Okay, so this is very important. I missed the part, that is half an hour. The division capable of preventing the passage of flame for the first half an hour, and for flame, and it is for smoke also it's written. For an half hour for the standard test, the insulation should be that on the opposite to a fire, the average temperature will not rise above 139, and above the original temperature, not more than that. 225 at any one point, and B15 must prevent. Okay. So class C, these divisions are constructed of approved combustible material, do not need to meet the requirement. And class B must prevent this. Three divisions are constructed of approved non-combustible material, do not need to meet the requirement for limiting the passage of smoke and flame, nor limitations relative to the temperature rise. Combustible winners are permitted provided they meet other requirement. Fire resistant doors and door fitted to the bulkheads and decks is to be as far as practicable at least equivalent to the bulkheads or deck in which they are fixed. Watertight doors need to be not to be insulated. Okay, so this is all about your doors. Now, what are the contents of fire wallets? So, what does the fire wallet comprise of? So, fire wallet is basically a kind of fire wallet basically comprise of the cargo storage plan, then general arrangement plan, yeah, if necessary, storage plan, and MSDS of the cargo stored, and fire control fire plan, and total crew list and emergency contact details in case of an emergency to whom they have to contact, and yeah, this is all about. Can be added more detail as well, like general engine plan, shell expansion plan, ventilation plan. I don't know why it's mentioned the ventilation plan. Okay, ventilation plan, fire equipment plan, position of watertight doors, stability information, cargo plan, cargo manifest if carried, crew list, electric data. Okay, electric data, cargo plan with any dangerous. I don't know. This is totally a bullshit, I guess. Now, what are the contents of a fire control plan? So, what does the fire control plan consist of? So, there it is written 18 points. So, the fire control plan gives a location of emergency escape devices, location of the fire extinguishers placed in accommodation in all the ships, and locations of all the ventilation system as well. And it also gives the details of the type of fire doors, and it gives the details of locations of the uh, SCBA sets, and location of the fire station, uh, location of the this what we say location of uh, quick closing valves, then and then the location of and what all and the locations of this is there, and the location of um, location of all the ventilation which has to be stopped, and location of all the to say location fire control plan, and it also consists of all the detection, fire alarm detections, fire smoke detectors, location of that, then general range, a fire alarm where it can be used to raise the alarm, and location of yeah, this is all about which I remember. Let's see what's written here. Control station line. So they have said sections of the ship which are enclosed by fire resisting bulkheads, control station on each deck, particulars of the fire detection, fire alarm systems, that is smoke detection systems, the sprinkler installations. Okay, sprinkler installations, location of fire extinguishing appliances, location and number of firemen's outfit on ship, location and number of EBD on ship, ventilation closing arrangements, exactly, ventilation fan, fuel, oil fuels, fire pumps, control, etc., quick closing, remote operation positions, exactly, primary and secondary escape route from engine room and accommodation. Okay, primary and secondary escape from engine room and accommodation, location of international shore connection. So this I have missed. International location of shore connections, then locations of fire hydrants and hose locations, ship particulars, locations and number of fire pumps, location and number of fire pumps, spaces protected by fixed CO2. This is very blunder which I have done. Locations of all the fixed CO2 and fixed dry powder, any other fixed appliances. Okay, Now coming to the working of DCP, how the DCP works. So DCP works on the basis of basically it has a nitrogen cylinders, and once a piston of a nitrogen cylinder is released, then it goes to the main canister, main container, and builds the pressure, and simultaneously it builds the pressure to the other cylinders of nitrogen, which releases the air gases and create pressure on the container, and the same open the distribution valve as well. This distribution valve, after reaching a certain pressure at the connect container, releases the basically from this distribution valve, the releases of fixed DCP takes place. So this is a very basic idea which I know. Let I guess I missed something. The first thing is that when we open, like what we open is one cylinder wall we have to open, and from that it will go to the directly container, and it will open the distribution valve, and simultaneously the other cylinder pressure will also create a pressure on the main container, right? So what is the name of the main container, and what word I have to use to say, like first what we initially do. The DCP system comprises steel pressure vessels, cylinder cylinder banks with manifolds, distribution valve, gas release arrangement, hose station monitors, pressure gauges, and safety valves. Cylinder banks with manifold, cylinder has a pressure vessel, cylinder banks with manifolds, with manifold, distribution valves, gas release arrangement, hose station, manifold, distribution gauges, monitors, gauges, and safety valves. When the nitrogen cylinder is open at the control station, okay, at the control station I have to use the word control station, the gas passes to the container and open the required distribution valve, and the same gas simultaneously open the series of nitrogen cylinders near the DCP container. Near the DCP container, the nitrogen gas released from the series of nitrogen enters the container and build up the pressure of the container. When it reaches its required pressure, the main powder valve opens and dry product flows to the appropriate release station via it opens the main powder valves. So this I have to use the main powder valve. I have missed this word. Main powder valve. Main powder valve. Main powder valve. Main powder valve will be open, and from that the extinguishing will take place. Main powder valve. And dry powder flows to the appropriate release station via the distribution manifold, and from the main and dry powder flows to the appropriate release station via the distribution manifold. The discharge of dry chemical powder is constant until the most of the DCP is used up. Okay, now requirement for emergency generator. I guess it's kind of bit important question, like we need to have by heart it. So emergency generator, the requirement is that if basically it provides source for the equipment which has to use in emergency, critical equipment which need energy sources like the navigational equipments and main engines and all. So and deck lights, emergency deck lights and all. So it will give power source to that, and at the same time it should come on load within 45 seconds. If it is not come on load, a visual alarm should come in ECR room, and visual and audio alarm should come in the ECR. No mention how it. And apart from that, within 45 seconds. Okay, now it should be able to work at 0 ambient temperature easily, and uh, it should have, if the temperature reaches below cooling and all, a proper heating arrangement should be there. And and another requirement is such that uh, this generator should be able to work in rolling and pitching of 10 to 20 degree, 22.5 degree, 10 to 22.5 degree, and the flash point of the fuel used in this generator should have be at least 40 degrees Celsius or more than that. And apart from that, in passenger vessel it should be able to work for 36 hours, and in cargo vessel it should be work for another 18 hours. And anything which I have missed. I don't think so. Let's go. Emergency switchboard and emergency, and it should be located on the continuous deck, above the continuous deck. Okay, so easily accessible, na? One can go there. So the requirement says that emergency switchboard and emergency generator should located above the uppermost continuous deck, and driven prime mover with an independent supply of fuel having a flash point of not less than 20. Generated power should be capable supplying all those services that are essential for safety in an emergency. 36 for passenger, 18 for cargo ships. Generator should be easily started at 0 degree, and if it is below this, heating condition should be there, and a 45 degree and 22 degree or inclined degree, and list up to 20 degree or inclined 20 degree thereafter forward. 10 degree. Okay, so very 22.5 degree is the rolling pitching and 10 degree trim. Okay, forward and aft. So if fails to come on load, an indication. Okay, so this is all about emergency generator room. So maintenance for fire main, fire pumps, hydrant, hoses and nozzles. So what I have seen on board, there is no any as such requirement like you have to do these that. There is a proper PMS schedule which I have seen, like on a monthly basis. Coming to the point of nozzles and all, once open the box, fire box, and just see whether it has a proper nozzles, hose in proper conditions, and it should have a F key of it, and and coupler are there, and that's it. It should be in a working proper hose should be inspected, should be in sorry, hose is not to be inspected. Box should be checked in a good condition, and locker it, and should have a proper locker also, so that hose is kept in the box in good conditions. And apart from that, coming to the point of fire hose, nozzle and hydrant should be checked on a monthly basis, like on whether it should not be hydrant should be, the hand wheel of the hydrant should be free, and it should not get stuck while using it, so it should be free always. And apart from that, coming to the point, annual basis, on annual basis fire hose testing should be carried out. Basically it's not annual also, it is done in 5 year. The hose testing should has to be completed in 5 years, so we have to, normally company as per SMS they want to do it in a 1 year, all the hose testings to be done. This is, we have to do all the hose tests should be tested in such a way that in a 5 year all hose tests is to be hose test is done, and the worn out should, the damaged hose should be rectified and placed in. And apart from that, on annual basis, I guess hose, nozzles, what else we can do is we can just do the pressure testing of all the lines, fire main lines. We have to pressure test at like at what temperature, what pressure they are main to. So we have to, like on the main emergency fire pump, and do the line test of the main fire line, and at the same time nozzles should be also checked for any kind of damage, and provided isolation valve should also be checked in at the same time. It should not be tightened, it should be free to use, it's greased properly, and all the hydrants should be greased properly on a monthly basis. And I guess I've given enough bullshit. Now let's check what are correct and what is wrong. Monthly, verify all fire hydrant, hose and hose are in place, properly arranged and in serviceable condition. Tadang, correct. operate all fire pumps to confirm they continue to supply adequate pressure. So this I have told, yeah, guess this I have told, yes. So operate the fire pump to confirm they are the continue to supply adequate pressure. Emergency fire pump fuel supply adequate, and heating system in satisfactory condition applicable. Emergency fire pump fuel supply adequate and heating system in satisfactory condition applicable. ओके, सो emergency fire pump के बारे में भी बोल दिया. सो उनका हीटिंग सिस्टम देखना है, उसका फ्यूल जो है वो एडिकेट है कि नहीं, है ना. क्वार्टरली वेरीफाइड और ठीक है यार, ये सोने पे सुहागा वाला काम है. एनुअली क्या क्या दिया है. विजुअल इंस्पेक्ट ऑल एसेसिबल कंपोनेंट्स फॉर प्रॉपर कंडीशन. फ्लो टेस्ट ऑल फायर पंप फॉर प्रॉपर टेस्ट एंड कैपेसिटी टेस्ट. इमरजेंसी फायर पंप विद आइसोलेशन वॉल्व क्लोज्ड. सो फ्लो टेस्ट करना है, आइसोलेशन वॉल्व क्लोज करके भी एक बार चेक करना है, ठीक है, कंडीशन कैसी है कैसी नहीं है. सो फ्लो टेस्ट ऑफ ऑल फायर पंप फॉर प्रॉपर प्रेशर एंड कैपेसिटी. फ्लो टेस्ट ऑल फायर पंप फॉर प्रॉपर प्रेशर एंड कैपेसिटी. Flow test all fire pump for proper pressure and capacity. Test emergency fire pump with isolation valve closed. Test